Welcome in, everybody. How's everyone doing today? Yeah, so. Right, first, today we're gonna be programming, maybe some gaming, and chatting about stuff. Okay, second, where the fuck have I been? You know, I've been wondering that myself. No, so, couple of things. The week before last week was finals, so I didn't really want to stream then, especially because I stream really late. And then after that, I did want to take a couple of days to rest. After that, so last week, I don't think I talk about it too much. I mean, I have it in the tags, but I have ADHD, and to help, especially with like school and stuff, I take meds to help. The problem is that some of these meds raise your blood pressure, and my family already has a history of blood pressure issues. So, with all that, I needed to keep better control of it in other areas of life. Right, food, exercise, and importantly, sleep. And I wasn't really doing that as much as I should have. So, kind of, I guess, not really a good way to describe it, but like an ultimatum from my doctor was that she wouldn't be able to give me the meds if the blood pressure got too high. Part of the requirements for taking this meds that your blood pressure is under a certain number, and she was not happy with the numbers. So, with that being said, I've been trying to sleep more, take care of myself a little bit more, which is why I haven't been streaming at all for the past 2 weeks. I want to try to get a better, more consistent sleep schedule down so that I'm not putting so much pressure on my system to kind of cope with me going to bed whenever the fuck I want. Has the sleep schedule been working? Kind of. I already don't sleep very well, so it's a process. And this is a reminder to everyone else. As much as I do joke about it, take care of your bodies. It is important. Situations like these kind of suck when you have to rush to fix years of mistakes. Okay. We're done with all that shit. What does that mean for streaming going forward? I definitely won't be streaming as late. I also probably... I want to say Sunday is probably the day that I'll be streaming most. You'll see me most on Sunday. I'll try to put in some streams throughout the weeks from probably like 9 p.m. to 12 a.m. PST. But I can't say which days I'll be able to stream or which days yeah, like which days I'll be able to stream or how long I'll be able to stream on different days, when I'll start streaming on different days. That all depends entirely on the workload that I have from classes. Next week is a new quarter, and I think the classes should be a little lighter on the homework, but I have no idea, so we'll see. Basically, I'll stream when I can. I don't know, maybe we'll get a more consistent stream schedule once I figure out how the classes go. But I don't want to promise anything that I can't, or make any promises that I can't keep. Yeah. So I will try to stream a lot more on Sunday. I have been inconsistent with that. That is just my bad. But throughout the week, and then throughout the week, I'll try to put in a couple of streams here and there. Shorter streams, probably less. Maybe some gaming. I want to say probably mostly programming, like we've been doing. Yeah, so that is the plan for the future. Right. Programming. Oh yeah, if you have any questions about like how that stuff will work, won't work, I don't know. I'm always happy to answer questions. And yeah. And then I need to be more consistent with posting in the Discord about stuff. Speaking of Discords, there's socials, there's the Discords, which would normally, I swear, I've been better about the announcements before. Announcements, schedule updates, stuff like that I post that in the Discord. And then if you want to watch VODs and stuff after they get deleted off of Twitch, what's it, like 14 days? Or is it 27 days? I think it's 27 days. Some shit like that. You can watch them on YouTube. Almost all the VODs get posted to YouTube. Also, I think we are going into ads now? Maybe? So I will explain kind of what we're going to be working on today after ads are over. If the ads ever decide to do. Okay, well. Yeah. So. This one. Okay. Basically, well, first I'm gonna be moving a bunch of code from here. Oh, we don't need that. Into this, because it started as a side project that I wasn't gonna spend that much time on or that much effort on, and then it got really big, so I'm giving it its own project. I've done a lot more with like a lot of this more professional-esque stuff, just to kind of learn, mostly to kind of learn how that works. I don't think there's anything actually super professional about this. I don't think I'm gonna post this to like, or publish this like PyPy, or PyPy is it's like where I install like packages from. So if I say, I don't know, pip install numpy, I already have numpy, but this goes and checks on PyPy. So that's where like a bunch of people will post packages that they made for you to use. I don't know if I'll put this on there. Maybe I will eventually. Right now it's just working on it to try to clean it up into something that is at least semi-professional. Okay. Yes, I know this is an... I think... hi. I just made. No, this is my own stuff. So if I have import pi as np np dot. There we go. There's the ads. Sorry, I wasn't looking at that. Zeros. I don't know. Maybe was it shape? 3, 3, 3. Yeah, 3, 2, 3. Good enough. Print repr r. Something I learned recently is that apparently when you use repr, which is this method, it's supposed to give you back like a string that's built in such a way that you can create the object again by calling eval. Eval is a Python method. So if I say eval, I don't know. So there's two. There's exec. I forget which one does which. I think exec does eval. Yeah, evaluates an expression. So if I were to do, I don't know. And times 2, like this. Okay, let's say I commented this out, and yeah. This evaluates one line, one expression. I think, because if I just do this, and then I print it from out here, it returns it. Exec just does the lines. Yeah. Okay. Apparently, eval is, or repr is supposed to give you back a thing that you can use to make a string that you can use to make the object again when you run it through eval. I didn't know that was a thing that you were supposed to do. I mean, I guess, just eval. NumPy import array. I mean, I guess I think I need to do that. Wow. So that's something new I learned. So that's probably going to change how I structure all of this. And this instead should be handled by string. Okay. Where is... like I said, first priority is just moving stuff. One, design. You just go there, yeah. Sure. Side projects, what else? We have base paths, which should go in here. I think this exactly goes in here. Yes. Yes. Yeah, I know I need to fix a bunch of stuff, but just there. Nope. Side projects, we move path masks over here. And features. Yes. This should be import or from typing import protocol. Now that'll be how we migrate. I think the two things that I left. New. This isn't supposed to be professional stuff. So this is, or like part of the actual package. I think I would probably just put drawn there. Where's draws here? I guess. All right, bunch of things we have to fix, but this I think is, so we pulled that one, and then this, we have to move those. This one we also need to put into two different ones, we said. So primitives, I think, go so math, I'm gonna create primitives. That's how you spell that, right? Primitives. There we go. Found it. Okay, new Python file. Primitives. Yes. New Python file. Helper. And the two functions that we have are trig, so I probably want to separate them like that. Okay, we have the files. Now we migrate. Okay, primitives. No. This goes in here. Fine. Wait. Where was imports? And then from call to what is Typing import callable. What is this one? Where do you want me? Collections? I'm sure. Let's see, import callable. What, now you want to organize imports again. There. Happy? Yes. Oh. Yeah, who would have thunk that they already made a class for this. What string? Oh. I assume it already does that. If I had to guess. List of any list of string any. No, you do not return a string. You return yeah. And then I need to fix this. I should actually just keep doing this. Place with new. With string logic and this. Okay, I think that's all the primitives. This one is cool. This is a rule. I think it's formats. Formats. I think it's the one that I want. Yeah, we'll put one to do instead of like 3 of them. That makes more sense. Like that. And we put one at the top. Oh, and we already have the JSON dump. Line too long? Yeah. That is fair, that's a very long line. I think that is everything for primitives. Alright, one thing I do want to check. If name equals main, Nope, there is nothing. There is no doc tests in here, but I wanted to. Okay, yeah, it's now prints that instead. You don't really need testing. Okay, these primitives. Features we'll deal with later. Deal with you later. This, that. This. Oh. And we'll just call this helper. Yeah, that's more specific. Now that's where we put this stuff. Yes, I know you want to organize. Oops, that. Imports and optimize them. There. Yes. Okay. Cool. Oh, right, I forgot. They have very poor understanding of how args works. Okay. That's annoying. Yes. Don't I need those? We'll see. Okay. Fine. fine. We'll figure out how to fix that later. Last one. Minus. Wait, no, not you. It's math.primitives import other units bit type prebuild func inform from import smp import JSON. And for all of the other imports, I'm just gonna grab it from the top. Oh. Hello? Nope. That's not good. Did we crash? What's going on? Nope. Okay. Looks fine. And imports, and then organize imports. There. Math.helper import angle norm, and it is, what else is pyfloat display? That's fine, we can fix that. None of this is red now. Okay, you're happy. That is this one done. Okay. Okay, these, it's fine, it's also fine, that's fine, yeah, that's fine, and types, what did I move to? Moved control shift minus, moved path base path and path mask, path types, what else do we have? We have yes, I remember we have stateless path and then stateless dx path. Dot is it type? 4 dot types import path scalar. Path scalar. Nope. We're trying one path scalar like that? Yes, I think we do. Class. Okay. State this dx protocol at dx. And I can't combine them into one. We just want to move types out. You can move types out. I think that's fine. Okay. I don't think I ever explained exactly what I was doing. I moved draw. Now we just have to go fix everything. Fix this. Fix this. Fix draw. Find path. And yes. Okay, I mean, well, this is kind of an idea of what we're doing. In a lot of computer science, when you're talking about specific shapes that, let's say I want to make a shape that is like a circle, but on one side there's a spike. You can either, there's a couple of ways you can do that. You can either say, well, it's a circle, and then I put a triangle on it. But if you just want to draw the outside line, what happens is that we make what's called a path. And a path is just at some time, usually called t, for obvious reasons, where are we on the path? So if I have a line, so that's way too zoomed in. So let's say, I don't know, the box starts here. And I say, well, the box, this entire thing happens in 4 seconds, usually. It usually doesn't represent an actual time, or it can, for like pathing in games and stuff, for like NPCs or objects. But a lot of the time it's just some units. But I've seen it called seconds a lot, just because it's easy. So let's say this box happens in 4 seconds, and each side takes 1 second. I have one function that says from t equals 1 to t, or from t equals 0 to t equals 1, we're on this line. And, I don't know, at t equals 0.5, we're at this. And then at t equals 1.5, we're halfway through this box. And then t equals 2.5, we're here, and then t equals 3.5, we're here. So, then when I go to draw this, I essentially say, alright, well, give me a bunch of t values from here to, from t equals 0 to t equals 4, and I'm just going to draw all of those points. And so it does, and then you get a box. That's all a path is in essence. Now there's a bunch of different ways you can make a bunch of different paths. Obviously the most basic path is a line. You start at a place, you end at a place, you have a start time, you have an end time, And don't worry about that. Yeah, so when I say at time t, where are we? We do what's called linear interpolation. A lot of the times you'll see it's shortened to lerp. We take our start point and we say, let's say the start point is 0. No, I don't think that's right. That's wrong, right? Isn't it? The 2... Is it? Am I an idiot? Oh, that's fine, because this is supposed to be end t. Like I was saying. We say, so the start point is at its strongest when we're the farthest away from the end point. So this is end t minus t. And then we take endpoint, that's just times t. This is assuming that start is greater, or start is smaller than end. So if we're at time, if start is 0, end is 4, or let's say that first line, end is, start is 0, end is 1. You say, well, one minus 0.5 is 0.5. So we're half being held by the start point, and then 0.5 times endpoint. So we're half being held by the endpoint. We're halfway in between the two. Very simple logic. Dxat, with some of the paths that I have, we use the derivative. That's just where are we going and how fast are we getting there. So that is this divided by this, which should be, I don't know why I'm changing anything here. That doesn't matter. This would be, well, we're going from the start point to the end point. So end point minus start point. That's the direction that we're heading. And how fast do we get there, or how fast are we going there? Well, we do this entire distance in end minus start. So this should be end p minus start p divided by end t minus start t. A couple of things I should probably rename just for more clarity. But yeah. And then all of this, why? Okay. Yeah. I don't know why I wrote it like that. And then another one that you hear about sometimes is called a B-spline. Actually, who the fuck was that named after? I know it was named after somebody. B-spline. Who named it? Oh, it's just called, it's a basis spline. Okay. So, that makes sense. Basically, the idea is that you have a set of functions, and each function defines how much each control point controls where we are at any given time. So let's say I have a function I have a what is this? Oh wait, no, this is a basis spline. This is one from here to here, and the control point is here-ish. I think I actually have it. Do I? Do I have it in draw at the bottom? No? Oh, wait. Nope. I've gotten rid of it. Oof. Well. Base path here. This one's a lot more complicated, but the idea is, well, I can either define all of the functions, and that's cool, but also then I need to define all of the functions, and that's a pain in the ass. Or I can say, well, I have control points, and each control point, in this case, this is an equally spaced B-spline. Basically, each control point, when I make the knots, is here. This says what time each control point is active at. So let's say we're doing let's say we have 3 control points. The start and end are included in the control points. So it's 1, 2, 3. And let's say this happens from t equals 0 to 1. So then we would say, well, at t equals 0, the start one is active. This one is active, and then this one is active because of how the basis spline works. Now you can change how the knots work, but I wanted this specifically to be anchored, which means that the line goes through the start and the end. And to do that, you have... Alright, I keep getting mixed up. Basically, I say whatever the power is. The other important thing with the B-spline is that you have a degree, or a power, because if we go back to thinking of this as a bunch of functions, maybe it's like, I don't know, t cubed, something times t cubed plus something times t squared plus something, right, all the way back. This power would be the highest power of t in our polynomial. Right, the way it works is that you have a polynomial for each control point. So, I don't actually know why this works, but I do know it does work. But by saying that there are this number of start t and this number of end t in the knots, and then I just have this will find a bunch of numbers between there that are equally spaced between start and end. And it finds a set of these. Again, I don't know why making the knots work this way does what it does, but it probably has something to do with, actually I have no idea. Why? Yeah, actually no, I have no clue. And then, okay, without getting too into the details, basically, instead of saying, well, I can define the functions, like I was saying before, instead of defining the functions, I can say, well, this function is like something times another function at the previous degree. And then I can just keep doing that backwards until we get to degree is 0, which is why in both of these. So I call this same function get basis again with p minus 1. How all of the other stuff around it works, yeah, I no. It does work, and there is math behind it. I've seen like papers and stuff published about it, but I couldn't be bothered. All I know is that to find the current function, we find the previous function, and then once we get back to degree is 0, which is why you'll see this up here, when p equals 0, well, either we have control or we don't. When p equals 0, this is it's called a step function. From some point to some other point, from some time t to another time, one point has complete control, and then at some switch point, it teleports all the way to the other point. So when you have a degree 0, you have a step function. When you have a degree 1, I think you have I think that's a linear function, I think. And then once you get higher than that, you get curves and stuff. This is a degree 2. Basically, there's a bunch of cool functions that you can use. B-spline is one of the ones that I heard about that I've seen used to make nice curves that go between a bunch of points that you can shape really easily. And then I wanted to make a way to interact with that and take a function and change it or create functions super flexibly. So I started making a tiny project for that, and then it got really out of hand really fast. So before it got super messy, I decided that I was just gonna put it all in its own separate project with its own separate folder and everything to move it away from everything else. And then I also wrote a design doc, which is massive because I have a problem, okay? I think of something and then I think, hey, this is really cool, and then I think of all the ways that it could be used really cool. But hopefully now that it's down, I don't try to just keep shoving things in. If I want to add something, I put it in the design doc, and then we'll get to it maybe. Okay, I don't want to delete this yet in case I missed anything, so I'm just going to close it. And then I'm going to go back and fix everything. God damn. I did want to see protocol on if the subclass is a certain Is it worth it? Yeah. So math is, I think we'll just put a helper dot py. This def Okay, constants. Any spaces. Typing import any. Base sets. I should just put this in args. Base sets. Any. Base for base and base sets. Argument of type what? Be assign. Why is it a string? Why are you? Oh, I'm an idiot. It's single. And so now you are just any, and then okay, fine. No. Yes. Cool. Happy? Yes. Okay. Now I want to make sure all of these work. Core dot features import stateless stateless dx. Brace path. Start point. What do we say? This was a dot nd array, just some nd array. Nd dot nd array, and then from the types we import path scalar. Path scalar. don't you like? Yes, I know. It's because you weren't supposed to take a self argument. This. Collection. Collections. Collection. Nested. That's scalar. Or of F. That's just scalar. Wait, yeah, here. Nested scalar. Wait, start P is a P dot ND array. No. Path nested scalar. What don't you like? Why? Oh, because N goes before S, I guess. Okay, fine. I'll rename to start. And not NT, NP. There. It's types. Types is here. And we take this and we say ND array of path scalar. I think no, you don't like that. It's is it ND array like this? ND array. Oh, that's importable. NumPy dot typing import ND array. Just like this. Path scalar. Does it work like this? No. No, I just import it directly. No, you don't like this. And you don't like that either. What do you like? Oh, okay. Yeah, so we'll just put in ND array and call it a day. guess we do kind of need the generics. Do we want to add those back? Yeah, I guess. So if we do this and we say this is T is path. What? Oh, path scalar there. You meant the world to me, and when you cry for me, you just a variable I can set. Can I set path t equals float? Can I do that? Or is it self dot path t? Yes. Okay. This requires testing. What? I think we just define a class. Class my class. I guess class type is either an int float. Int self You don't like quarks, right? Oh wait, no. From typing import any. That's fine. Class type self dot class type equals quarks dot pop class type else type self dot equals type of does class generics do anything Because if it's just for type hints, then I is... to the generic type. So if I do want to actually use it, I need to store it somewhere else. Yeah, so the generic isn't helpful at all. Okay. That's just something we need to store. Yeah, no, we're just gonna undo all of this. Nope, we will do this. Vision is type of path scalar equals float. Then we'll just put it down here, I guess. Is it? Equals type of path scalar. Oh wait, no, it's the brackets equals get what is it called? It's not casting, it's end type? End type? No. Oh, I guess priority. Right now, items, any items, marks, any. Yes. Nope. Path scalar. So if we put just 3 dots there, that goes away. We still need to typing import any. If pop precision. Otherwise, we take all of the items and we have to find the highest floating point type. check if it's a NP integer. Types. Okay, now. Umbrella type. What is the integer umbrella type? I know the... Actually, I have no idea. Nope. So it's just np.integer? Really? Okay. If I'm casting up from an integer, I go to the type that's one higher, right? In float. So if I'm going from... Wait, do I? Because I forget. I know... you can leave it the same. Okay, I think for safety we probably go up. Well, do we need to? No, I think we can say the same. Just any number. What does school have to say? Okay, let me just look at this. Some and P have different byte sizes. What is int P? Alias for the signed integer type, one of byte short. Oh, okay. An arbitrary byte sequence is void. Cool. Uh-huh. Oh, I didn't know that int was flexible. That's interesting. Okay, what does numpy... Oh, God. Okay. Okay, that's not what I'm worried about. I just want... Oh, it... Wow, 80-bit precision? Damn. Python's floating point are usually 64 bits, equivalent to float 64. And with more precision, with this is possible. NumPy depends on the hardware, and specifically x86 machines provide hardware floating points with 80-bit precision. Provide this as their long double type. As we see, standard for Windows builds makes long double identical to double. NumPy makes the compiler's long double. I 100% sure I use MSVC, so main, where are we? Main. Alright, NumPy is in P. Precision, resolution. Okay. That doesn't mean very much to me. Oh, it is float 64, that's why. P dot double. Oh, precision is an integer. Oh, this tells you how precise it expects that you can do. Let's see, so float 96. What? Oh, I didn't know there was a thing. Oh, lovely. No, stop it. Oh, is it just floating? That would make a whole lot of sense if it was just... That is instance np dot float f16 np dot float 16 to, I don't know, 32 f64 and f16 and and then I did see 128 np.float. Okay, typing extended precision. Float 128 2. So does it exist or does it not exist? It doesn't exist. Or? Okay, Google. Oh, extended precision. Okay. Wait, what? Then why do I see... This is for which version of NumPy? Does NumPy have float 128? Oh, that's why. Okay, so it can exist, but it doesn't always exist. Oh, okay, so... okay. Well, it doesn't really defeat the purpose. It's still much, much faster than Python. Faster than... Well, I mean, if you're going to write it in C, then I don't know why you would be using NumPy for some things. I mean, I guess it does array packing, which helps a little bit, I guess. Yeah, who knows. So, it does have float 128, but it doesn't really. It only on platforms that support it. I guess that makes sense. Wait, no, it's a list of np dot list of type of np dot floating, I think. No, not floating like that, floating like this. Okay, so for each item, we check if it's integer. np dot type path float equals float np dot floating, and then we're just going to use that. Because this one always encompasses that one. If this instance item path, wait, no, actually we don't, well, I don't think we need those. We might need them, but I think we're only working with floating point, so this should be fine. np dot number even, because it should only output floating point. We never want to work with integer, because integer, that's the big difference when you're working with Python and NumPy, because NumPy isn't written in Python, it's written in C. And in C, if you have an integer and then you do division, 5 divided by 2 is 2, not 2.5, because you took an integer and you divided by an integer, so the result is an integer. That's specifically because of how the... Okay, so in Python is what's called a dynamically typed language. Okay, so if I said int, for example, that is why I can do this. I can say, yeah, items is something, probably. I don't know what it is, but it is, it's a lot of something. I think I can actually specify this to path scalar, but I don't have to specify the exact type that I am using. The problem with C is when you translate between the two, is because Python lets you do this. So if I have 4 divided by 3, for example, instead of the compiler having to know what this output type is, when Python is processed by an interpreter, it's a program that goes and looks through line by line and just processes the code at runtime. So when I click the run button, all of the processing happens. In other languages, compiled languages, they don't do that. When you click the run button, they can't do anything yet. First, they have to take your program that's written in nice human language and turn that into efficient machine code. Or they convert it into an intermediate step. So if you've programmed with Java, it'll compile it to a .class file. I believe C and C++ convert directly to .exe or .dll or stuff like that. Well, they convert to exe, DLL. DLL is for taking a program that's already compiled and using it in your own code. Stuff like that. You take nice human code and turn it into efficient machine codes that the runtime, so if you were programming with Java, you have the Java runtime, or a lot of the times you'll see it called the JVM, Java Virtual Machine, because it's a program that takes your Java code and actually don't know exactly what the JVM does. I know you have the Java runtime environment, JRE, which is something you'll see if you download a program and it'll be like, yeah, we can't do anything. We need the JRE. I've had that happen before. Which it shouldn't happen because I have all of that nonsense, but that was a different story. When the runtime environment on Windows, the C runtime or .NET runtime, because C, C#, C++, R#, I think is what it's called. Whatever. Or F#. Yes, that's what it is. F#. All of that compiles to exe, which the runtime looks at each of those instructions and translates that into specific CPU instructions. It looks at this and it's like, okay, so you're going to take one integer, and then you're going to take another integer, these two numbers, and then you want to add them together. And that's going to make this integer, which we're going to store in this memory location. The reason these programs turn it into an intermediate language is because everyone's CPUs and setups are different. And if I were to say, yeah, I want the CPU to do these specific instructions, some CPUs might not be able to do those instructions. A common one is when you're doing math in addition. Most modern CPUs have 64-bit registers. A register is like a small bit of kind of like memory, but it's where the CPU will put a number, and then it'll put another number in the registry below it, and then it'll do an operation on them. So let's say addition. Because addition is a very specific operation that is done by each, or bit by bit. It puts the two registers, and then it clicks the add button, essentially. If I want to take a 64-bit integer and another 64-bit integer and add them together, well, if my CPU has a 64-bit register, it just puts them there, and it's great. And then it combines them, and it gives me the result. Yay, I did math. If the CPU has, let's say, 64-bit registers, but I ask it to do 128-bit, so double the size. If I ask it to do addition with that, the CPU looks at this and then breaks. It doesn't know what to do because it doesn't have 128-bit registers that can be used. So the CPU just can't run that. So I can't turn my program into CPU instructions. When you compile a program, it turns it into a nice intermediate that is much faster and much easier to read for the runtime. So the runtime can run very fast, very smoothly. The compiler will also decide a bunch of things beforehand on how things should happen. So a bunch of configuration happens. It makes the program easy for the runtime to read. And then the runtime knows the whatever CPU you have. It knows the environment that it's running on, and it will figure out the exact instructions that it needs to send to the CPU for the CPU to actually do the program. So, with that, the runtime, because it's giving instructions directly to the CPU, the runtime needs to know what type, how big, let's say, the integer is that the CPU is going to output, because it needs to tell the CPU where to put it. If the CPU gives it a 64-bit integer, and it tries to put that in a 32-bit memory window, something breaks. So it needs to know the type that the CPU is outputting, and the runtime knows stuff based on what the compiler knows. So the compiler needs to know what type the CPU is outputting. And the compiler knows what type the CPU is outputting based on the types that the operation is happening on. If I take two 64-bit integers and I add them, the compiler infers that I'm going to get a 64-bit integer out. And that works great until you get to division. Because if I have a 64-bit integer and I divide it by another 64-bit integer, maybe it outputs another integer, but a lot of the time it's going to give you a floating point number, or a decimal. But the compiler doesn't know that. The compiler expects an integer. So the rest of the floating point number just kind of gets chopped off. And that goes... somebody else figures out how that works. Or, if you want to do math with floating points, you need one float in there. So if I have and because NumPy, now we get back to this, because NumPy is written in C, if I tell NumPy that it has an integer, 64, then anytime I do operations on it, it will only give me back integers. There are some cases, I think, where it specifically changes the type so that it works nicer. But from what I understand, if you have an integer array and you divide it by some number and you get some floating point numbers, it just truncates them. It deletes the part after the decimal. And that's bad because we want to do math that's useful. Which is why we're going to convert everything to floats. You're only allowed to be a float. This should actually even be floating. Now, hopefully that makes sense. I think I went on a little bit of a tangent there. Okay, maybe it was a lot of a tangent. But that's the end goal, is that this kind of figures out what floating point. For example, if I have a bunch of float 16s, then I'm just going to leave it as float 16s, because the user clearly intended for it to work with 16 bits. If you want more than that, then you use float 32, and then the default is float 64. The way sizing works with floating points is even weirder, because logically you would just keep two numbers. You would think you just keep two integers, that one's before the floating point and one's after the floating point. And I mean, even the one after the floating point can get one more, has one more, is an unsized integer, or what's unsigned, not unsized, unsigned integer. Right? You just have two numbers, one before the float and one after the float. Makes sense? No, because you can't represent super large numbers or super small numbers that way. So the way that generally works is, actually, I should be able to find something. It is floating point representation in computing. Yes, this is a good way to do it. Basically, okay, so this is the international, what does that stand for? International something electronics, Institute of Electrical and Electronics Engineers. Yeah. They're basically, it's like the central-ish body on a lot of, most computing stuff in general. So like hardware and low-level software. All software, really, and then specific like languages will have their own requirements and body on top of them. So it's a lot of different people telling you how to write different things, but the idea is that they all agree with each other, for the most part. So their standard says that there are two types. You have single precision and double precision. Single precision is 32 bits, double precision is 64 bits. So a lot of the times if you work with low-level programs, or something like, I think one that a lot of people know a little bit more, because most computer science classes in like high school, I don't know why, but they use Java. So this would be your standard float. A float is 32, and a double is 64. I could go on an entire rant on Java. I don't like it, but it exists, and a lot of programming classes decided, you know, we're going to teach people to program and work with computers, and it's going to be great. We're going to use the one programming language that decided to be very different from everybody else. And why? I don't like it. Anyways. The actual math of how you turn a random floating point into this, I still don't get at all. But there are 3 parts. It has it up here. 3 parts. Sine. Wait, is it? Wait. Sine, exponent, and that. Wait. Oh, how do you store it? Oh, significant is. Oh, yeah. Okay, that's fine. It's similar, like it says, to scientific notation, where you have some number times 10 to some power, but because bits and computers in general work in 2s, the base is 2 instead of 10. Which means that the math, when you're actually trying to figure out what the precision is, gets a little bit more complicated. Because it's not just shifting numbers forward and back, it's multiplying and dividing by 2. It makes it a little less intuitive, but obviously 2 is a much nicer number in every computer system, so we use 2. So right, the 3 parts, sometimes you'll see it'll be unsigned, and then the mantissa, which is the significant, it's this number. The number that actually means stuff. That number will get 1 more bit of space. So unsigned basically means, yeah, everything is positive. Either you have, well, it's either positive or negative. If I think it's on, then it's negative. If it's off, then it's positive. Or you just say, yeah, fuck it, it's all positive. Don't worry about it. And then everything is, then you have 1 more bit of space to make things happen. So yeah, so like it has here, you have the sign, you have the significant, it's the number that holds the information, and then the exponent says how big is this number generally. And why did we choose this? Or not we. Why did some people who probably have a little bit more forethought than I do, why did they choose this? Because if you were to just do 2 integers that were side by side, the range of numbers you can represent is very small. So we trade some of 1, clarity, and 2, the precision is not the same throughout the scale. If you have a very small number, so something like negative, okay, we're gonna do this in the editor. I like that UI better. A good way to visualize how exactly is decimal from decimal, import decimal, yes. So if I have a number, decimal represents things as infinite precision. It's a little bit more efficient than just the 2 integer side-by-side method, but it's kind of the same. It's the same idea. Instead of having the CPU do all the math of adding the floating points together, it takes your big, long floating point number and breaks it up into tiny chunks that it then sends to the CPU. So the CPU only has to deal with small parts, and we don't have to worry about all of the, how do you make this efficient for storage because when you make a decimal, you are specifically acknowledging, yeah, this isn't going to be efficient, but I can represent any fucking number I want, so it's cool. For example, if I say decimal, okay, so if I have a float and I say 1.2, okay, let's just a bunch of numbers. Okay, there's this many digits. We're going to print this as a string, and we're going to print decimal of this. Like this, it just cuts off there. Because it just can't represent anything with more precision than this. Python does a very nice thing where it acknowledges that floating point isn't precise all the way, so it automatically truncates floating point numbers at specific lengths when it says, yeah, this is not precise anymore. And again, this is the benefits of having a system that is entirely interpreted. The language just kind of figures out it can do a lot more with even basic types, because floats aren't actually small pieces of data, they're entire objects. So Python has a bunch of logic on what floats are good and how you count them and make sure that they're stable. And so, for example, if I do, I think it still has this issue, but if I do this with like, for example, if I do, let's see, I think it solves most of this. Let's put this all the way at the front. And then in other languages you'll see this happens, but I want to test how does this happen. Let's see, okay, that's 4, 1, 2, 13, that's 0.5, so that's a 7, 1. That's another 5, that's 4. That's another 5, 9. That's 1, 2, 9, 0. I know at some point it stops being bad. Yeah, like this. I think I did this right. We'll see. Let me actually just print this. I might have fucked up the math. Would not surprise me in the slightest. 9, 2, 1, 9. Fuck. Is that a 6? It's 3. Should be 1, and then you get a 5. Yeah, that should be 6. Okay, I'm an idiot. I feel like I heard somewhere that Python also has this issue, but maybe it doesn't. Maybe it handles the logic better. But the other issue with this is that, for example, if I do this, 2.49, well, this should be a decimal with 2.49. It's not. Like, not at all. Which is the main issue with floating point numbers, is that when you take one floating point and you convert it up or down, and is it the same every time? I believe it is. Yeah, this is it. When you convert a float up or down in precision, obviously here when I go from 64-bit precision to infinite precision, you get a bunch of bullshit. And that can make math imprecise, which is why NumPy will recommend that you use np.isClose to check if two types or if two numbers are similar, because it takes the types of the two numbers into account and picks. It has a default tolerance. I think it's 1e to the negative 5, which is small enough that it should weed out most floating point imprecision. And then, and then when you're doing math with floating points, that can get imprecise because of all this bullshit. So, yeah, so that's why, and as much as this is annoying, it is all the way back here. That's a lot of decimals of usable space. So it's not too bad. It is annoying though. Especially when you start doing this. I don't know if we'll ever get into if this will ever get into super hard math, but it will get into there's division, and then there's some exponentiation, which can be a little bit fuzzy with floating points. So all of that can be a little weird. That's why it's important to be very clear on how things work in the specific language that you're using. For most programmers, to be fair, I don't think you'll ever experience anything like that. It will never matter, because you never need more precision than 15 decimal places of precision. If you really need more than that, then you really shouldn't be using a primitive. Or you shouldn't be using float or float 64. You should just be using an object. .NET has, I think it's GMP. I think I tried downloading GMP and then it broke for some reason. I have no idea. GMP I think is it's arbitrary precision. A floating point arithmetic, I think. That's not what it stands for, but it's arbitrary is the same as infinite. It's like, I think sometimes you'll see them used interchangeably a lot. Arbitrary and infinite precision. From what I understand, arbitrary precision is when you choose a precision, but that precision can be anything. And then infinite precision is when the object adapts to whatever precision you need. But I have not seen very much in the way of differentiating between the two. I think most of the time it's it's the same thing. Alright, what was this? What is int? Python int size. Oh, right, there's the size of. Main print size of 2. Where does size of come from? Size. Right. 2 dot. Oh, I forget. Maybe it was from C types? No, I thought that was for, C types. How to get size of Python objects. Oh, get size of. This print this dot get size of 2. 28 bits? Okay, what if I do like that? Oh. If I do that, do you just... Oh, it does. That's... Well, I guess this is the solution. We just use sys.get size of. Nope, not here. It is types. Import sys. I think that'll complain and go to the top. No? Okay. And then I need to import warnings. Import warnings. Yes, I know it's unsorted. Sort it. If its size is less than 16. Oh wait. I have to put that up on np dot float 32. I don't think I ever want to use float 6, right? Yeah, no, for this I don't think we'll ever put float 16 on there. Float 64 else if types of delta and float 64. Wait, no, yeah, this should be 32. And else warnings dot warn. Right. Maybe inaccurate. We're just gonna float 64. Elif is this item p dot integer. If it's an integer, we just cast to the same type. If wait, no, we just ignore that. If np dot int 16, yes. Wait, what? Yes, what is it? Int 16. As I think we will use warnings, but and what is np.int16? Import npy as np and np.int16. Yeah, it is a class. What are you on? Is instance 2. Okay, yeah. So I don't know what you're on about. It is a class. Shut up. I guess if we're... Oh, it's not int, we're float. Float 32. And ad starts in a minute. And thank you for sticking through the ads. I do appreciate it. It helps support the channel, and well, I mean, yes, it helps support the channel, but stuff from that goes towards, will go towards a model, and when I have time, probably first, when I have time, probably goes towards emote first, and then a model, hopefully. We'll see. That's probably way down the road. It is on np.in16, p.int32. No, if they asked for np16, and they want float 16. p.int32. Nope, not int32. We want a float 32. elif. Generic type with type arguments? Okay, explain this. What is Space Pirate on about? Just need to tell you to shut up. Is instance if, and then if no np.int 96. Yeah, no, I didn't think so. np dot. Otherwise, we just append the type. Oh, yeah, I should just do this in 16 for float 16. Yeah, I'm just gonna delete this one. Float 32. $64. You're unhappy with that. And then else, what? Else we found something we don't know what to do with. So we... size. Size. Inaccurate results. What does stack level do? Stack level. What's warnings? Warn. What do the arguments do? Warn. There. Okay. So then we should make yeah, class warning or cast warning user warning. Warning new code and warning inputs. Warning. No, you don't have this. Windows get raised. Oh, okay. Yeah, that's not quite what I want. Oops. Warning class? Where is it? We go to warn. We go to warning. Go to resource usage. This is, yeah, really, this is just generated from the stubs, but okay. Someone will want the warnings to always appear at call sites outside of a package when constant stack level does not fit all call paths or is otherwise challenging to maintain. Supplied, it must be a tuple of strings. When prefixes are supplied, stack level implicitly overridden to be max 2 stack level. What? Yeah, okay. To skip file prefixes, warn skips os.path dot port lower or dot one way. I think we just put this and this is fine. Stack level. What does stack level do? I think we just don't change anything. Stack level 1 is fine. What stack level? Okay, yeah, and that's just this does float 64. Typeset return np dot float 32 in typeset return np dot float 16 in typeset else. Wait, what other? There's float 64 16. Okay, 16 32 64. There's only those options. about it. Yes. And shut up about that. Cool. What else is here? It's line too long. No. This is fine. Okay, so we have get priority type. So then what do we do here? We put type equals get priority type. Get priority type of what? Oh, right. And this is why. So type path nested scalar. P dot what? NP dot end the array. The array. No, stop. Not like this. Like this. Dot d type in np dot is instance np dot floating. What's about it? Yeah, you don't know. It's fine. Type set element. D type. Wait. Oh, wait, no, type. I need the type of this. No, we don't want to use it in here. What about like this? Okay. That is... is that why? Yeah, okay. Flow... we're just going to turn that off file wide. I'm going to switch this off for just a second. Up about it. Yes, happy, cool. Nope. Why? I changed that though. I fixed that in here. Unknown member type equals false. Oh, none? Is this what you want? And then unknown argument type. None. Unknown. Yes, I know it's already in there. That's argument type. Okay. Now. Port. Okay, what is this? This is unknown. This. I don't care enough. MP dot int 16. Do I need all of this? Yes. Oh, I should actually just... I wonder, can I just say, is it np dot get results type start point endpoint? Start P and end P. Now I. Okay. The better way to do it is like this. np dot array of start point, np dot array endpoint, and we do this if vargs dot pop decision And that's why we can do this. Args. Precision equals back type. And then the rest of the quarks come after that. Yeah. Okay, then we go to A, B, C, and yeah, I don't think we need any of this. Lovely. This we... if result type and T if start T instance T else np dot float 64 is fine. This should be np.float64 because just like NumPy defaults to this, we should also default to that. Okay, but what? Alright, we need to fix that, but that's later to do. What did I say? I have it on somewhere. Math primitives, right? To do. Space path. Path mask is like this. Yes. Cool. out because precision equals path dot precision. Okay, so this is where I think we need to def cast this is a path scalar, and this is type of path scalar. What do we return? We return a path scalar. Okay, so we take yeah, we might have to end stream soon. Okay, so I'm gonna put a do implement. There's a couple of things that we need to oh my god, stop. We need to fix, but I mean, we made some progress. I think that's good. Yeah, like I said, I will stream when I can. I will try to stream as many Sundays as I can, at least, if I can't fit streams in throughout the week. Other than that, streams are probably going to be shorter. Or if you weren't here, I talked about this at the beginning of stream. Streams are probably going to be shorter when I do stream during the week, because I'll be streaming from 9-ish, or whenever I can start, and I have a hard stop at 12 a.m. PST. So I want to say maximum we'll stream 3 hours throughout the week, and then I probably could have streamed a little bit longer today if I started earlier. So I will try to do that more. I do want to give you guys more content. Oh, hi, Dino. Welcome in. Sorry, I've been sleepy, lurking. The OVO was productive? Yeah, I think it was. Damn, my alarms are crazy. I think it was productive. I think we got some good stuff done. But yeah, welcome in. I hope that you were able to get some rest. Also, yay, the fucking shout out works. I'm not dumb. Oh yeah, it's reminding me if I need to work on the better one. I'll do that off stream. Yeah. What was I saying? I got completely sidetracked. Fuck. Alright, streams. So I do want to give you guys more content, but I do have to balance my own life and health with all of that. On top of that, maybe if I have the time, I want to start learning some editing, so I can put some kind of content out on YouTube besides just VODs from stream. Maybe I'll edit some streams down, I don't know. But I don't expect any of that anytime soon. That's just something that's potentially there. It's in my head. It's swirling around with the brain juices. Dino, you enjoy listening to me talk through my work, and you love the shout out? Yeah. I was pretty proud of that one, I'm gonna be honest. Yeah, no, I appreciate that you were lurking, and it's nice to hear that my sometimes incoherent rambling is at least nice to listen to, even if it doesn't make sense. It doesn't make sense to me half the time. Okay. Raiding. Who do I want to raid? Who's live? I think we'll raid Ayane. I think that's cool. Dino, sorry, give me a second. I will read that after I start this down. This, yeah, she's been live for just a little bit. There are the raid messages. Bottom one is if you are subbed. Top one is if you aren't. And what did you say? Dino, if you always liked my voice, you just have no idea what's going on. Well, I appreciate that. It really does mean a lot to me that people just kind of like to listen to me. That me just doing what I'm doing is entertaining. Right. Let's go say hi to Ayane. She's really cool. She does DBD sometimes. I think she's been doing DBD more. She plays cozy games and some horror games too. Yeah. Raid. I did that. I did all the things. I'm getting better at this, I think. I'm professional, I swear. Remember to take care of yourselves. Dying is in fact bad for your health. Don't be like me. Get rest. Thank you for the last minute hydrate. Yeah, get some rest, take care of yourselves. I really appreciate all of you. And I will see y'all next time. Bye.